This series of tests shows the effects of 3 different control system response speeds on dynamic fume hood containment. Here you see a fume hood with a 6-foot wide sash opening. The tracer smoke is generated by a theatrical fog machine. In each test, an operator will walk up to the fume hood and raise the sash, creating a realistic challenge to the hood's ability to capture and contain fumes. In this first test, we demonstrate the effect of a lab control system with a less than 1 second speed of response provided by the Phoenix system. Notice the excellent containment of fumes and the absence of turbulence in the fume hood chamber. Now we'll demonstrate the same test but with a 3-second response delay. Notice the poor containment of fumes. In a live lab, the escaping fumes would be present but most likely invisible. In the third test, we show a 6-second response delay. Again, watch the dramatic amount of smoke leaving the hood. Also, note that the smoke that was released from the hood is eventually pulled back past the operator into the hood, creating a long second exposure. In this test, we return to the system with a less than 1 second response time and demonstrate fume capture and containment when the sash is open to a mechanical stop. Again, notice the excellent fume containment and stable airflow within the hood. The next test shows a control system with a 3-second response time and sash opening to the same mechanical stop. Again, we see that fumes escape from the hood when the sash is open, and there is an increase of turbulence inside the hood when the sash is closed. This test shows a control system with a 6-second response delay and a sash opening to a mechanical stop. Once again, note the loss of containment and the fumes drifting around the operator's head. The previous fume hood containment tests have been conducted using a sash opening speed of about 1.5 seconds. This speed is used for similar tests in the ASHRAE 110 standard for testing fume hood containment. This test again shows the fast response time of less than 1 second, but with a much slower sash opening rate of about 3 seconds. With a 3-second response delay, this test shows that even with slow sash opening speeds, there can still be loss of containment if the control system doesn't respond quickly enough. This final system test shows the increased loss of fumes even when the sash is raised slowly. The control system response time in this test is about 6 seconds. In this final series of dynamic containment tests, we will use a fume hood with a horizontal sash opening. In this first test, you see the effect of a lab control system with a less than 1 second speed of response, like that provided in the Phoenix system. Observe the good containment of fumes and the stability of the air in the fume hood chamber. Now we'll demonstrate the same test, but with a 3-second response delay. Notice the poor containment of fumes. In the final test, a lack of containment is demonstrated when a 6-second response delay is introduced into the system. Again, there is a dramatic amount of smoke leaving the hood. Also notice the excessive turbulence inside the hood when the sash is closed.